As you can see, there's 5 bananas plus 2 apples gives you 760 grams, whereas 3 bananas and 4 apples give you 680 grams. So you have to find out how much does 1 banana weigh. Now, if it's a real life question, you probably wouldn't use algebra. Like, what would you do? Yeah, say again. Anyone? So this is what I would do. Watch this. This is what I will do. I'm going to... Now, we can't compare them because, like, they're different, right? How do I make them comparable? You can actually... No, watch this.
Add more bananas.
Add not more bananas, but I'm going to double this. Now, why do I double this?
So now there's like 20 bananas.
Now I could compare.
Why are there so many bananas?
I'm going to double this. Now, if I double this, what do I get?
15, 20.
What's the other 5? What's the 20?
20. Okay. Now, can you see why I double this? But now I could compare them. There's both of them 4 apples. So now, can you see why I double? Because once I double, they both have the same amount of apples. Therefore, the extra banana contribute to the extra weight. Does that make sense? So both of them has 4 apples.
So now you're just getting rid of all the...
So if I subtract them, let's subtract them.
Yes, get rid of
1520 minus 680. What would that be? 840. So the 840 come from the how many extra bananas?
7.
So 1, 2, 3. So you have how many left? 7 left. So let's highlight this. Control D. So that's 7 bananas. So now I can work out what 1 banana is. What's 1 banana? And what would that be? Oh, let's use a calculator. Oh, 1 banana is 220. So let me show you how to do it algebraically. This can be expressed purely by algebra. Now, can you see that if I subtract these two, the extra weight is due to the banana. The extra 7 banana contribute to 840 grams. Does that make sense? Because both of them has 4 apples. Before I can't compare them because that's got 2 apples, that's got 4 apples. That's got 3 bananas, that's got 5 bananas. So I have to double the first one in order to compare these two, right? Does that make sense?
That's a lot of bananas.
So I doubled this one so that both of them has got 4 apples. So now the extra weight are due to the 7 extra bananas. Yes? Some people get it, some don't. Okay, let me try again. Let me think of another way. So I doubled this. If I double this, so they have the same amount of... So I have the same amount of bananas. Same amount of apples. So if I double the apples, so this I get rid of that plus. No. So you got 4 bananas, 4 apples here, 4 apples there. And the extra 7 bananas give you the extra 840 grams weight. Okay? So what we're going to do, let's use algebra. So if we let... Alright, let's look at algebra a bit. We got... Let B be the weight of the banana, A be the weight of the apple. Apple and banana. Okay, so that means I could write 5 bananas plus 2 apples gives you 760. And the other one, 3 bananas plus 4 apples gives you 680. Does that make sense? Let me write this again. 5 bananas plus 2 apples give you 760. Call that equation 1, call that equation 2, right? What we're going to do is to double equation 1. Just like we doubled the number of apples. Now watch this, when I double this, what do I get? I get times it by 2, I get 10 bananas plus 4 apples gives you 1,520, right? That's equation 3. That's 3. I double equation 1.
So there's only 2, not 3.
That's the third equation. Got it? So I changed equation 1 to get equation 3, right? 10 bananas, 4 apples. And then what I do is we're going to subtract 3 by 2. Let me write 2 again. Now watch this, watch. Alright, watch this.
This is like the Olympics.
Now I'm going to subtract them. Let's subtract them. I'm going to write 3 minus 2. Right? If I subtract them, what do I get? 10 minus 3 is 7 bananas. See, there's 7 bananas. But the 4 apples gets cancelled. So you end up getting 840. So therefore, to get 1 banana, you divide 840 by 7, which gives you 120. I thought pictures makes more sense.
So can I list a real life application like this? Like, I'm not going to be like, oh, I have 5 bananas, let me just whip out my pen and paper and figure this all out.
Now, think of it this way. What if you have a big container, like a big truck with all the bananas? You're not going to weigh them, right?
So that's not a shape.
You're not a shame.
But there's something else that you can't weigh easily. What if something's very heavy?
Then why couldn't you pull out 1 banana?
But what if it's not a banana? It could be a car or it could be something else.
If you can measure 1 car, if you can't measure 1 car, how are you going to measure 20 cars with 3 apples?
So maybe in the factory, they made a car, they weigh the car already. But then when it comes to you, you don't have a big weight. You don't have a big scale to weigh the car. Yeah.
Already told you away. You're working together on this.
But there could be other things you want to work out that you have to use simultaneous equations. Well, we'll see some examples of this. Okay. All right. Let's move on to do the next question. So now we know how to solve this by, this is called elimination. So elimination requires you to subtract or add the 2 equations, right? All right, let's solve the other question. Okay, let's look at this one. Number 1, number 2. So in this case, we're not going to subtract the 2 equations. We're going to add the 2 equations. Why do I add them? Let me see. So when you add them, that's why 1 plus 2. Now, if we add the 2 equations, what's x plus negative x? 0. They get eliminated. And then you do negative 2y plus 5y. Yeah, but I need to leave it there. I know, that's how I draw a line there.
So what, that's just 3y?
Yeah, 3y. So you add the x to the negative x, add the negative 2y to the 5y, add the 1 and the 2. So when you add them, can you see the x gets cancelled? It gets 0. And that becomes 3y equal to 3. And what's y equal to? Well, x gets eliminated, right? That's called elimination method. Now, once you get y equal to y, how do I figure out x? You sub it back into either 1 or 2. Yeah, elimination. You do the elimination before you do the substitution. So from 1, you get y, x minus 2y equal to 1. Now what's y equal to? 1. So you put 1 there. So therefore x equal to 3. Got it? So put it back in there. Say again. 2 times 1. Times. Yeah. All right, let's move on to the next one. Yeah. after I finish. Okay, let's rub this off because it's a bit confusing there. Okay, let's continue. We're going to call this 1, call this 2. We're going to subtract the 2 equations. So you go 3x. So you write 1 minus 2. Why do I subtract? Because if you subtract the 2, negative 2y minus negative 2y. They cancel. Yes. So when they are both minus or both plus, you subtract. But when one of them is plus, when one of them is minus, you plus. Does that make sense? That's how we know when to add, when to subtract. That's the elimination method. I'll say it again. When the signs are opposite, 1 plus, 1 minus, you plus. When the signs are the same, you subtract. Yes, you subtract. All right, let's continue. So what do they have? So what's 3x minus 5x? Negative 2x. What happened to this? 0, yes? Equals to negative 6. Now how do I find x now? Yep, y equal to 3. Next one.
That'll make it good, sir.
That's 3. Now how do I find y? Sum it back into 1 or 2.
2.
So let's substitute into 1 from 1. You get 3x minus 2y equal to 5. Now x equal to 3. Right? Minus 2y equal to 5. So 6 minus 2y equal to... Oh, no. That's 9.
Wait, y equals 2, sir.
Y equal to 2? Yeah. Negative 2y equal to negative 4. Y equal to 2. You're right. All right. I'll give you a minute to absorb that. After I finish, one more page. There is. After I finish. All right, let's move on. Next page, when you're ready.
Some concern for Kyle's health. It might be suffering from Tourette syndrome.
No, we're not finished yet. One more page. All right, let's move on. Soon. Okay, let's move on. Let's do the next one. Okay, Declan, shush. Okay. All right, let's move on. Okay. We call this equation 1, call this equation 2. And then what we do is this. We're going to solve them. Now, if I add them, they don't cancel. If I subtract them, they don't cancel either, right? Because 5x minus x is 4x. So in this case, I have to change one of the equations. The one I change, let's change 2. We're going to multiply that by 5. Now, if I multiply 2 by 5, what do I get? You get 5x plus 35y equal to 125. We call this the new equation. Yes, yes.
Like with bananas.
Yes, like the one with the bananas. And then I'm going to write 1 underneath. Like that. I've changed number 2 by multiplied by 5. Everything by 5. Yeah, everything by 5. And the top stay the same. Now, why do I do that? Can you see the number in front of x are the same? Are they the same now? Now I could eliminate. You must make the numbers the same. Subtract them, yeah. So you go 3 minus 1. What's 3 minus 1? You go 5x minus 5x. What's 5x minus 5x?
No X.
0. What's 35y minus 2y?
33Y.
33y. What's 125 minus 7? Minus 7. 125 minus negative 7.
How did I get
132.
so I can't do that?
Does that make sense? Because can you see they're the same number now? So when I subtract them, they get eliminated. The x gets eliminated after I time. When one of them doesn't have a number, you times it by 5, right? When that doesn't have a number, you times it by 5. Then they're the same. Yep. Okay, now how do I work out 132 divided by 33? What's that equal to? 4. Y is equal to 4. How do I find x now? You go back to either 1 or 2. Let's use number 2. From 2, say again. You can use 3 or 2, but 3 comes from 1 anyway. So you can just use 1. Yeah, you can use 3, but the numbers are bigger. So it's better to use 2. So x plus 7y equal to 25. Change, put the 4 into y. Say again. X plus 7 times 4. So x plus 28 equal to 25. What's x equal to? Negative 3. All right, continue. Have you all finished? Got it? Minus 3. All right, try the next one. Next one's a little bit different. Yeah, you have to change both. This one you have to change both. You're right. All right, let's do this. Okay, I'll finish. I'll leave it up later on. Let's go through D. Now D, you can't just change one, you have to change both. So it's like the lowest common denominator. What I'm going to do is I'm going to make y the same. I'm going to times 1 by 2. You get 8x plus, or you can do the other way around. You still get the same answer. You get 36, call that number 3, and then times number 2 by 3, which is 9x minus 8y, no, minus 6y, equal to 15, number 4. Right, let's move on. Let's move on. Okay, now can you see it's like the lowest common denominator. If I times this by 2, times this by 3, can you see they are the same now? So when they're the same, but they're opposite in sign, do we add or subtract? Add. Let's add them. So you go 3 plus 4. Okay? 8x plus 9x.
Sir, stop the pace.
Plus 6y plus negative 6y.
You're so tasty.
Okay, let's start again. 8x plus 9x, I add the two terms. 6y plus negative 6y. And then you do equal to 36 plus 15. And then what you do is you're going to add the two terms. 8x plus 9x is 17x. Notice that the 6y and the minus 6y gets cancelled. Equals to 36 plus 15, which is 51. Okay? So the y gets eliminated. So you get x equal to 51 over 17. So 51 divided by 17, you get 3. So you write equal to x equal to 3. And once you get x equal to 3, you sub it back into either 1 or 2. So I'm going to substitute into 1. So let's do that. So you got 4x plus 3y equal to 18. 4x, now x is 3, so you replace x by 3, which is times by 3. 3y equal to 18. 12 plus 3y equal to 18. So we subtract both sides by 12, which is 3y equal to 5. No, 3 is 6. So y equals to 2. So the answer is x is 3 and y equal to 2. Okay, I'm going to repeat myself. I'm going to go through the whole process again. Now listen carefully. The hard part is to knowing what to do first. So the first part is the 3y, I'm going to times by 2 because the other number is 2. But the second one you times by 3, you times by 3, yep. Yeah, in this one, I could make the first two the same, or I could make the second polynomial the same. Doesn't matter. You get the same answer, yes. But the reason why I make the second one the same is that it's easier to add the equation than to subtract. So if there are plus and a minus, I prefer to get rid of that than get rid of the x, because it's easier to add. Because if you subtract, it's a little bit harder. Okay? All right, can you write this down? If you have still questions, just let me know. I'll come and help you. Have you copied it down? All right. Okay, now get started with the work. Sorry about that. Lanciare.